me. Okay, so once you find the sales price by either finding 80% of 1,600 or 20% of 1,600 and subtracting, then you have to add sales tax to the sales price. Okay, so number one is a three-step problem. Find the sales price, then find the sales tax on the sales price. Okay. All right, number two, it says the sales clerk makes 3% commission on the ring. Now, salespeople don't make commission on sales tax. So when you find out how much the sales clerk makes, you are not including sales tax. So for number one, you're going to take that answer before you added tax to figure out how much the sales clerk makes. You're finding 3% of the sales price. Do you have any questions? Anybody? Anybody? Okay. And then number three, it tells you exactly what to do, guys. It says take your final answer from number one. So your final answer from number one, then you're going to do the simple tax on it. You're going to take that number, you're going to multiply it by 3, and then multiply it by 0.12 to find out how much interest they're going to add to the price of the ring. Okay. The question is, at the end of 3 years, what is the total amount Donnie will pay for the ring? So you're going to have to take that original price from number one, your final price for number one, and add the interest to it. And that would be the grand total Danny would have to pay, or Donnie would have to pay if he uses this, the payment plan thing. Okay. If he takes out a loan. Okie dokie. Now, guys, you're not going to get full credit if you do not show your work. That's part of your points. So even if you get the right answer for number one, there's no work, you're not going to get full credit. I want to see how you're getting those numbers. Okay. So are there any questions about Friday's assignment? All right. Like I said, most of you have still not done it. So you guys need to do it. I mean, you're going to lose points because it's late, but at least that's much better than, a 0. So Karen, I got yours. You got full credit. Evan, I see yours. I haven't had a chance to grade it yet. Isabella, I see yours. I have not had a chance to grade it yet. Jenna Kate, you got full credit. James, you got full credit. Layla, you got full credit. The rest of you that have submitted it, you made some errors. And I put on there what you missed. So you still need to do that. If you've already submitted it and you correct it, you won't get points off for it being late. Okay. I just realized that you guys all have zeros for this week's lesson. I don't know why it automatically gives y'all zeros sometimes. It drives me crazy.
I was
All
about
right.
to say something about that because my grade went down. I was like, huh?
Well, I heard somebody talking, but I have no idea what you said.
I was just looking at that earlier today. I was going to ask at the end of the Zoom why it keeps giving us zeros.
Yeah, I don't know. Why does it do that? If y'all notice that happens, just let me know and I'll take it off. So, well, I know what happens. Like if I used the assignment last year and I pulled it into this course, it uses those original due dates. So an assignment that was due last year, they think, oh, this person hasn't done it. I'm going to give them a 0. So I always try to catch that before I publish it, but sometimes I don't. So just let me know if that happens. Like if you have an assignment that was just published and you already have a 0 on it, let me know and I'll take care of that. All right, you guys. So today we're going to look at scale drawings. So I hope, right, if you did that sales price, oh, okay, Isabella, I think I just took care of what you're talking about. Okay. Now the ring on sale task, Isabella, you have published or submitted it, but I haven't had a chance to grade it yet. So if it shows a 0 right now, as soon as I grade it after class, it will go away. You won't see, it's not a 0. Okie dokie. All right, so hopefully you guys have your calculator, you have paper, you have pencil, and you're ready to go. All right, so just to confirm, I have marked the following people absent: Jaylee, Caden, Presley, Gabriel, Paris, and Tristan. I had marked you absent, but I see you now. So my bad. Bella, Isabella, and Lily, you have to have your camera on so I don't mark you absent, please. All right, so let me pull up our slide deck. Get my screens ready here. Okie dokie. Whoops, I didn't mean to hit that. All right, scale drawing. I hope you guys noticed that you will have to do your study guide this week, right? 7th grade. Oh well, never mind. That's not true. You have your test next week. Okay, thank you, Luke. All right, here we go, everybody. We're talking about scale factors today. All right, so look at this house over here. So a scale drawing is used to represent objects that are too large or too small to be drawn or built at actual size. So every time there is a new building that's going to be put up or a new house, they have this scale drawing. Well, why do they have to take the original size of the house and shrink it down to this paper? Well, because if the drawing was the same size as the paper, imagine how crazy that would be to carry those papers around and go, oh, here's the actual size of the house, right? That wouldn't make sense. So they take a picture of a house or a building and they shrink it down using a scale. They have to use the same scale for the entire house or building, or it's not going to really represent what it would look like, right? So that's what we're going to talk about today. We're going to talk about that scale factor. In other words, how much bigger or how much smaller will the actual drawing be, or excuse me, the actual building be according to the drawing. All right. So we've been using proportions. So here on this first picture, we have a big house, right? And the scale drawing is smaller than the original. So one thing you need to know about scale factor, so I'm going to say scale factor. If the scale factor is less than 1, that means the image is going to be smaller than the original. Okay. If the scale factor is equal to 1, that means the scale drawing and the actual building are the same size. They're congruent because 1 times anything is what you get, the other number, right? So if the scale factor is greater than 1, that means the image is going to be larger or bigger than the original. Okay, so since we have a big house and its image is smaller, that means the scale factor has to be less than 1. All right, so what they're going to do is they're going to take this, the information they have, which right here, they're telling us we're going to use a scale of 2 inches to 5 feet. So that's our first ratio, guys. Our first ratio is our scale, 2 inches to 5 feet. So in other words, for every real 5 feet in reality on this drawing is going to be represented by 2 inches. Okay, so they take this smaller picture, they put it on top of the second ratio because the small number goes with the small picture. That makes sense. And what we're missing is the size of the whole house, and that's where our X goes. Okay, so just like we've done in the past, in order to solve for X, we're going to cross, multiply, and divide. So our scale factor was 2 inches to 5 feet. We take the measurement in inches, and we want to see how many actual feet that represents. So what are we going to do? How do we solve proportions? How do we solve proportions? What do we do mathematically? We cross, multiply, and divide. All right, so what's 2 times X, guys? 2 times X. 2 times X is 2X. What's 8.5 times 5? Who's got their calculators? Hopefully you all do. 8.5 times 5 is 42.5. Y'all do this with me. And now to solve for X, what are we dividing by? What are we dividing by? We always divide by what's attached to our variable. So what number is attached to our variable? You got it. Thank you guys that are sending me the answers. I appreciate that. Yep, it's the 2. We're going to divide both sides by 2. So 42.5 divided by 2 is 21.25 what? What are we missing? Are we missing inches or feet? Feet. Yes, very good. Which makes sense because the bigger house must have the bigger number, right? That makes sense. All right, how do you feel about that? Pretty good? Awesome. All right, where could scale be used? Name 5 things you could use a scale for. So here we have a map, right? Definitely a globe. So what if your globe was the size of the actual Earth? There's no way you could put one in your house, right? What about my map behind me? If this was the actual size of those continents, I couldn't fit it in my cubicle. So that's what we have to use scale drawings for. Creating buildings. All righty. Clay, diamond, city, town, village. I love it. I love it. I love it. All right. So this is what I was saying earlier. If a scale factor is greater than 1, the original figure will be enlarged. Okay. Because you're going to multiply the original measurements by the scale factor. And if the scale factor is greater than 1, our image is bigger than the original. However, if the scale factor is less than 1, if it's between 0 and 1, our image is going to be smaller than the original. Okay, so you need to keep that in mind. And if our scale factor is 1, we would create a congruent figure to our original. And of course, you guys have access to my slide deck. All right, so it says to draw or construct shapes using scale factors. Let us look at an example. So here we have our original rectangle, and it says that we're going to create a rectangle with a scale factor of 2. So if we take those original numbers and we multiply them by our scale factor, our image is going to be twice as big as our original. Okay, so what is 3 times 2? Yep, what is 7 times 2? 14, you got it. So if we create a scale factor, our new rectangle, even though this isn't really twice as big, but the measurements will be twice as big as the original. So that's how you do it. You take your scale factor and you multiply the original coordinates or the lengths by that number. All right, any questions? Okie dokie. All right, so now we're going to look at this rectangle. Now, 1/4, is that greater than 1 or less than 1? If you ate 1/4 of a whole pizza, did you eat the whole thing or not the whole thing? You ate less than
No, you ate 1/4, which is 1/4 is less than 1/2.
It is. What decimal is 1/4?
0.25, I think.
Yeah, you're right. It's 0.25. So basically, when we recreate our new rectangle, our new one should be 1/4 or 25% of the original. Okay, so can anybody tell me my new coordinates? What's 1/4 of 8 and 1/4 of 20? Good, Luke's got it. To find 1/4 is the same thing as dividing by 4. So what are our new dimensions? Good, Karen. Good, Luke. Who else knows our new dimensions? Nevaeh knows them. Good. Finding 1/4 of a number means you just divide by 4. Good, Emma. Good, Jeremy. Good, Layla. Awesome. All right, so 1/4 of 8 is 2, and 1/4 of 20 is 5. There we go. So the new rectangle should be 1/4 the size of the original. Easy peasy, right? Any questions? Nope. Okie dokie. All right, so this time let us look at an example involving scale factor and area. So first of all, we have a rectangle down here that's a 3 by 4. Who can tell me what the area of this rectangle is? What is the area? Nevaeh raised her hand. How do you find the area of a rectangle, Nevaeh?
You multiply 3 times 3, and then you multiply 3 times 4.
And what is that?
That's 12.
That is 12. So if we blow this thing up with a scale factor of 3, what do you think the new area will be?
Well, 3 times 3 is 9, and then 4 times 3 is 12. So it'd be 12 and 9.
So what is 12 times 9?
12 times 9 is 108.
You got it. So the new scale factor, or excuse me, the new area is going to be exactly what Nevaeh said, 108, because we wouldn't just multiply 12 by 3, right? That's not right, because 12 times 3 is 36. We would have to multiply both of these numbers by 3. So really the scale factor would increase 9 times more than 12. So 9 times 12 is 108, just like Nevaeh says. Okay. And you don't have to remember that. You square, in reality, you're squaring the scale factor to find the new area. If you can't remember that, just remember, okay, well, I know what the original area is. And now I know I have to multiply both of these numbers by 3. And then to find the new area, I would just multiply 12 times 9. Okay. Be careful on that kind of question. Don't make too quick of an assumption. Oh, I just multiply 12 times 3. Nope, that's not right. All right, how we feeling out there, everybody? Good. Nice. All right, so I want you guys to try these. I want you to take the original figures, the original side lengths, and I want you to tell me what the new side lengths are going to be. We'll call this problem number 1. You're going to tell me what the dimensions are. We'll call this one number 2 with a scale factor of 1/6. Finding a sixth of a number means you divide it by 6. Make sure you read these questions carefully, and then we'll call this number 4. So I want everybody to try 4 problems, and everyone is sending me the answers. Ready, set, go. Everyone is doing problems 1 through 4. Everyone's working, and you're all sending me answers, please. Make sure you're sending me your answers. Jeremy, try number one more time. You got the 28, but the other number's not right. And make sure you're answering the questions asked. Like number 3, the question is, what is the new scale factor? Luke, you didn't answer number 3. You didn't give me the new scale factor. And your last one is not correct. Yes, Jeremy. Isabella, I think you got them, except the last one is not right, Isabella. And you didn't give me the area for number 3, Isabella. Nevaeh, I think they're all right, except number 4. Number 4 is not correct. Or is it? Yeah, I guess it is. Actually, I think I missed it. You're right, Nevaeh. I'm wrong. Good job. Jenna Kate, number 4 is not correct. Try those again, please. Okay, Caitlin. All right, everybody, are you done? Some of you aren't sending me answers. There we go, Karen. Yeah. Yep. And number 4 asked for the area. Oh, number 3 asked for the perimeter, you guys, not the area. Sorry, Luke, I messed you up. Number 3 asked for the perimeter, not the area. Layla's got number 1 right. Number 3 is not correct. Everybody keep working. Sophia, where's your answers? Wyatt, where are your answers? Christian, where are your answers? Kellen, where are your answers? Okie dokie, Layla. Christian Godoy, can you hear me? Are you doing math? Wyatt, can you hear me? All right, 30 more seconds. Karen, you are correct. All right, guys, we're going to go over these. If you didn't quite finish, make sure you're paying attention, please. All right, so number 1, we're using a scale factor of 4. Oh my gosh. All right, so we're going to multiply 3 times 4 and 7 times 4. So our rectangle should be 4 times bigger than the original, which is a 12 by 28. 12 by 28. Right on. Okay, thank you, Kaylee. So number 1 is 12 by 28. Because all we did was multiply 3 and 7 by 4. All right, number 2, we're multiplying everything by 1/6. The same thing as multiplying by 1/6 is divide by 6. So 24 divided by 6 would be, that's a terrible parallelogram. What, 4, right? And 1/6 of 42, in other words, 42 divided by 6 would be 7. So that is a 4 by 7 parallelogram. Got it? The next one asks, what is the perimeter? To find the perimeter of a figure, you add all the sides, correct? So our original perimeter is going to be 40 plus 40, which is 80. And then 30 plus 30 is 60. So our original perimeter is 140 centimeters. But if we use a scale factor of 4, our new rectangle is going to be a 120 by 160. And then to find the perimeter, we're going to add all those sides. Now, finding perimeter, it would be 4 times more the original perimeter, and that's going to be 560. And we get that by adding all 4 of those sides together. Okie dokie. And then the last one, it doesn't even ask what our original area is, but if we divide each of these numbers by 4, we get a 3 by 6 rectangle. And then to find the area of that rectangle, we simply multiply our side lengths together, and the answer is 18 inches squared. All right, who got them all right? Who got them all right? Luke did, Karen did. All right, good job, guys. If you missed one, do you see what your error is? Did you see why you missed it? No, yes, okie dokie.
It actually, when I looked at it, I thought it was 18 units squared, right?
On number 4?
Yeah.
Yeah, it is. So the units are inches, so it'd be 18 inches squared. That's right. All right, guys, good job. All right, so here are the answers, which of course we know because we're so smart. All right, now these are 2 good problems that you will definitely see in your practice problems this week. So if you have to find a missing side, and everybody needs to write this down. Not yet, Layla. Yes, at the end of class. Yes. All right. So the way we're going to do this is we're going to figure out what, we're going to use our corresponding sides. Okay. So do you see that this slanted part of the triangle here is 10 and this slanted part of the triangle here is 70? All right. So one of our ratios must be 10 over 70 or the opposite. I could have put 70 over 10. So they give us this side over here is 8, and we want to find out what is the length of this side. Okay, so we're going to use, if we do small over big triangle, small triangle over big triangle, in your second ratio, you must also set up small triangle over big triangle. So small over big, small over big. Okay, so here's our proportion. In order to find our missing side, how are we going to solve this proportion? What are we going to do? We're going to do cross multiplying and dividing. Cross multiplying and dividing. Yep. So 10 times x is 10x. 8 times 70 is 560. And then what do we divide by? Yep, we divide by whatever is attached to the variable. So we're going to divide both sides by 10, and 56 divided by 10, 560 divided by 10 is 56. So this side length is going to be 56. Okay, do you see how that works? All right, since they gave us this side, we can now figure out how long this side is. So we'll call this y. All right, so we're going to start again with our original ratio. Small triangle to big triangle is 10 to 70. And now if we did small to big, over here we have to do small triangle to big triangle, and we got 6 to y. All right, everyone tell me what the side length from E to F is. Send me your answer. Oh, Nevaeh's already done it. Everybody cross multiply and divide to figure out what y is, please. Good, Karen. Send me your answers. We're doing this proportion, everybody, right here. All right, if we cross multiply, 10 times y is 10y. 70 times 6 is 420. Good, Evan. Good, Luke. Good, Jenna Kate. And then when we divide both sides by 10, we get y equals 42. Good. Thank you, those of you that tried. All right, I want all of you to try this one. I want you to solve for x. So either you're going to use 4 over 6 or 5 over 7.5. Don't use both, only one of them for one of your ratios. Okay, so everybody try this one now. Ready, set, go. I only have one correct answer so far. Karen is correct. Everybody else has sent me an answer. Try it one more time. Nope. Good, Evan. Nope, Kaylee, that's not right, sweetie. I'm so sorry. Here's a proportion you can use. You could have also used this and you get the same answer. Nope, that's not right. Only have 2 correct answers so far, Karen and Evan. Nope. We're cross multiplying, dividing, cross multiplying. All right, if we cross multiply. All right, the right answer is 3, everybody. If we cross, there you go, Luke, you got it. So 6 times x is 6x. And then, yep, good, Jen and Kate. 4.5 times 4 is 18. And if we divide both sides by 6, we get x equals 3. Yep, good, Kaylee. You found out what happened. All right, and same thing. If you use a different ratio, as long as you set it up correctly, you're still going to get the right answer. Okay. This is 22.5. And then if I divide both sides by 7.5, I would get x equals 3. All right. Any questions? Some of you are doing nothing. Nothing.
X equals 6.
X. Oops. Oh, I did. I'm sorry, Nevaeh. You're right. Wrong. It's 3. It's 3. Alrighty. My bad. My bad. All right. So, guys, it really will only help you to come to Zooms if you participate, if you actually do the work with me. All right. So you all have access to my slide decks. So here is a video on scale drawings. So if you need some review after class is over, please watch this 8-minute video. Ooh, that was loud. All right. So, obviously a long time ago when I was growing up, we had to use maps to figure out where we were going. There was no such thing as a GPS. So we would get the map and, I'd ask my dad, we'd be going down to Orlando and I'd be like, how far are we? So dad would literally give me the map. I would have to use the scale drawing. I'd use my little pencil and I would figure out about how far we went on the map, and then I'd have to use the scale drawing and figure out how many miles we were away. And that's just what we used to do, you guys. I know, can't even imagine. Drove to Orlando using a paper map. All right, so using that scale drawing or that scale right here, if you were looking at a map, that would be one of your ratios. You would have to put that 1 centimeter represents on a map. Well, one centimeter on a map represents 20 real miles. Okay. So that would be one of your ratios, whatever that scale factor is, whatever the scale tells you, that would be one of your ratios. Okay. All right. So there are more practice problems that we are not having a chance to get to because our time is out. Or up, I should say. So you guys need to look at these examples. Y'all need to go through these, read these scenarios. They're going to set the problem up for you and make sure you understand what's going on each one of these problems. If you have a question, you need to let me know and I can walk you through it. Also, you need to go back and watch that video I was talking about and see, it tells you exactly what to do and it gives you the answer on the slide deck. All right, now there are several problems here that you can use and practice and make sure you know how to set them up. And then if you go to the next slide, it gives you all the answers. So take advantage of having all of these practice problems, okay? And if you need my help, you have to let me know. All right, so another math problem and the answer. Another math problem, and there's your answers. Okay, so you guys have stuff that you can do in order to get a little extra practice. All right, you guys, well, that's all I have for you today. Thank you for your attention. Everyone have a great day, and I'll see you tomorrow for social studies. Bye, guys. Have a good one.